Hello, Internet. So at work, my colleagues and I have a Hangman board on our whiteboard that every day we kind of choose a new word and try to guess it. We just kind of write letters on the board, and over the day, we kind of try to figure out what it is. It's been going all right, but I think we can do better. So what I'm gonna do, what we're going to work on, is we are going to write a Hangman solver. So what that's gonna do is I have a dictionary with 79,000 words and I have an empty C# program. We're going to write something that is going to, over the course of 6 or 7 guesses, we're going to figure out what that word is. So the way this works is when you get a hangman guess, you get a number of characters. So you get some number of characters. We'll say like 5. So you know you need a word that has 5 characters, which means you can go through that entire dictionary and eliminate everything that doesn't have 5 characters. That's the first step. The next step is the guess. When you're guessing, what you want to do, there's another video by Mark Rober. He's the world's coolest uncle. But he does a really cool video about how the statistics of actually making the best guess. And so what you want to actually do is get as close to the center as you can. If you're familiar with binary search, it's the exact same idea. You want to get to the center, and that way you can eliminate as much as possible, regardless of if you're right or wrong. So that's what we're going to be doing, is we're going to try to find what letter can we choose that eliminates as close to the middle amount of characters as we can. And then after that, we're going to just iterate over that. I think we can do that all in one video. It may run a bit long, but I'm going to try to do it all right now, just because I want to use it tomorrow. So let's get started. So all we need is, this is just a super simple C# .NET Core app. So we can run this anywhere. And I pulled this dictionary from, there's an online source from, it's very similar to the Scrabble dictionary. The official Scrabble dictionary, but there's a few extra words added to it. So we have that dictionary. We just need to first read that dictionary in. So we can do that with, how do we want to do this? Let's do a dictionary class. So initially the architecture here is going to be make things as we need them, which is not the proper way to do this. Text searcher, sure. My naming, as always, is terrible, but we're going to create something that can load in some sort of file. We're just going to load in this dictionary text file, and then that's going to effectively build that. And then inside of this text search, we are going to constantly reduce the possible answers until we get 1. And once we have that, we have our answer. So this needs a file name, which we can just do like this. And then we just need to store the total number of guesses. So we're just going to store a string with our possible guesses. So I'm planning on just solving a lot of this with LINQ because it's going to be easy. We're not going to get so much into the algorithmic solving of this just because I don't think we'll need to. There's only 79,000 words, which seems like a lot, but it's not that many. So I don't think we're going to run into any performance issues, and if we do, we can deal with it then. But it's going to be faster than a human, so I don't really care. Here we want to load a file. So we're just going to load file. Ooh, that's not it. Of our file into our possible guesses. So this is going to be mutable. This list is going to change over time. And so we're going to create that, grab our file. Ooh, that's not right. Okay. Apparently Alt-Enter, the hotkey it keeps displaying, is not actually how you do that. So we're just going to read all lines. I think this works. Yeah, so this is going to read out each line as a string into just a giant array, which is exactly what we want. So take that, give it our file path, and then just return a new array list. It doesn't actually really matter what kind of list we use, because, well, let's just do a list for now. A list of string, and we're gonna do words. So I'm gonna initialize it with the result from this, which I think this will work. Yeah. So we plug all that string array into here, and then that gets returned here, ends up in this possible guesses. And so we have a giant list of possible guesses. And so what we can do is we're going to have two filters. We're effectively going to filter by words or by letters, and we're going to filter by count. Void filter count, which probably isn't the best way to do this, but we're going to do it anyway. Is there a better way to do this? No, we don't need. So I was thinking we could actually store the size of each of these strings, but there's actually no point in doing that because we're only going to use this once. We don't care after we get through it. So words. As I'm thinking over this, I'm thinking it may get harder than I was thinking. Yeah, this is going to be... We're going to need more than this. So I'm actually going to store this as a dictionary. And I'll get to why in a second, because we are going to need a word description. So what I'm getting at is we cannot just do what I was going to do, just have the strings. It would work, but our algorithm would be wrong, because say you've guessed, say your word is and you've already guessed A and N, and you want to guess a D. That would actually eliminate and completely as a possibility, so it would no longer be a factor. But let's see here. Is there a way that you can actually keep it around? I get is what I'm kind of trying to get at, and I think there is. So no. Hold on. No. Okay. We'll get to that in a second. I am overthinking this, and that is not. Well, if it becomes a problem, we can fix it. But for now, let's just solve the basic bit. And we'll make it as complicated as we need to, and then we can filter everything out. Because this is all we need. Filter count, we are going to go through and say our possible guesses is going to be equal to, we're actually going to make this IEnumerable. So it's just an enumerable list. We don't care about what the format is. And what that lets us do is every single link expression returns an IEnumerable. So we can do possible guesses dot where. So we're just going to see where our word has word dot. Ooh, that's not right. There we go. Where the word dot length is equal to word size. And we're going to rename this to word size. There. And so we're only looking for words that have specifically that many characters. And then we just return it. We're going to actually want to completely render out this list. So we're going to do a toList on this. If I didn't do that, this would become a lazy expression and it would constantly reevaluate it every time we did it. So we'd effectively just be making a more and more complex query over time, which isn't necessarily what we want, because then we'd be evaluating this a lot. So we've got our filter count, which is going to just trim down our possible guesses. Remove with character. So this is going to remove all words with the character. So if you guess and it doesn't exist, every word with that character gets eliminated. Character remove with character. So this is in the case of a incorrect guess. This is what you're going to be calling. So possible guesses equals possible guesses where the word, contains. Will that work? Yes. Remove with character. Sure. Yeah, so this is just going to return, again, our same list, but if it has that character, it gets thrown out. So this is we missed. Oops. Next, it gets hard because at least in Hangman, you get actual references and it says you got something right here, or you got something right here, or you got something right in both of these spots. You kind of start building out part of the word, which actually really helps because it means we can eliminate a lot of things. So what we're going to do is just, I'm going to call it match. And this is going to be, do I want to use regular expressions here? Probably not. But we're going to anyway. We're going to do a partial word. Yeah. Will this work? So we're actually not going to do, regular expressions. We're going to do something like, so underscores, you can't really see that, but underscores in our string will represent empty spaces, things we haven't guessed. I don't think there's any character word in here that has an underscore. It doesn't. So we should be good there. So underscores will do it, and then you can just have other letters in there, and it will step over those and then match. We already know they're the same length, so we don't need to check that again. So possible guesses equals the possible guesses where the word dot matches string partial word. So we're just going to pass this in. I'm going to make an extension method that does this, and then we're going to toList it out and return it. And I don't know if this is possible, but I'm going to try it here. Public static bool matches string this dot. This string, we're going to pass in our word, the origin, and we're going to have a string, and we're going to call it the match. And we're just going to return true. I don't think this works. Yeah, so you can't create an extension method inside of something else. So I'm using Visual Studio 2017 for this. I don't recommend it. I was doing Visual Studio 2017 and just to kind of try to work out some of the kinks, because it doesn't actually really work that well. It's probably one of the most unstable versions of Visual Studio I've ever used. I don't know why, but I can't even open most projects. They just don't work. And I don't know what causes that, but it's really annoying. So we have this matches string thing. We are going to need to implement this. So I think we can just do for int I is 0. And we're just going to look at it character by character. For I is less than the origin length and just go over it. So we're going to have a private static read only. Let's actually do private const of our wildcard, which is going to be, which is going to be our, it's going to be the underscore. So we have our underscore there. And then we just need to check if it's the underscore, then we ignore that character. So if the or if the match, which is what we're actually looking at, if match I is equal to our wildcard, then we skip it. Then we do nothing. Continue. Otherwise, we want to make sure it matches. So else if our match I must be equal to our origin I. If it's not equal, then we return false. So we didn't find anything. But if we get to the end and we've still matched everything, then we return true. It's a match or a partial match. And that should be everything we need there. It should get us, yeah, that should work. So effectively how this program is going to work is it's going to be a single instance. You're going to be able to solve one thing per program run. So it's going to start, it's going to say, Hangman solver, because why not? Console write line, how many characters are in the word? So it asks you simply how many characters are there, and then you just need to give it that. So we're going to have an int character count, console read line, and we're just going to read in the total number of characters. So this needs to be parsed, so we're just going to do an int32 parse, and we're just going to parse out our console. So that should give us the total number of characters. We should be able to parse down this thing, and then we'll just keep guessing, and each time you'll have to actually input what the string is, which is not ideal, but it'll work, I guess. Let's see here. String program, cool, match, remove with character, and filter count. I think those are the three cases. So we have the origin, which is filter down. Then we remove anything. So if you guess and there's nothing there, then we remove everything. Otherwise, we have this match. So I'm trying to think how we actually want to set this up. There's a few ways to do it, and I'm not entirely sure what the best way is. I didn't actually really think I was going to put this together. I was just like, we'll just solve this on as we go. So don't know how this is going to go, but we have to know what we guessed and then figure out what the result is. So I'm wondering, do we keep the state? That seems like a bad idea. I hate adding extra, well, I mean, we already have a massive amount of state here. This entire thing is stateful, but I'm not sure I want to add more. Let's see, character count filters down. And then we want to search on this. Okay, so here's what I'm thinking. We're going to input the character you guessed, and then input the result. So you're going to do something like A. You're going to do type A, and then you're also going to end up throwing out, say, underscore underscore WX. I don't know, that's not a word, but anyway, you get this result. And since there's no A here, then you know that it needs to be filtered. So I think what we want to do is make these private. And throw another public void guess. So we're going to have the character, the guess character, and then the string result. So if result contains the guess, then there was something there. Otherwise, so in that case, we want to match on our result because we know that guess was there. Otherwise, we want to pull everything else out. So we're going to remove with character of our guess. So our guess failed. We didn't find anything. The match does not have that character in it. So we're going to actually pull everything with that character out of our list of tries, of attempts. That makes sense. And now that we have guess here, actually, we can actually public void calculate guess. And this is going to return a character that is the best guess. This is the hard part. I'm going to move it down here because that's all about processing this thing. Instead, we want to actually calculate what the result we're expecting is. And so what I'm going to do is create a dictionary of the character and an int, which is just going to count how many. We want to know how many words in our current possible guesses have each character. And we want to know what we've already guessed. Which means we need to know string current word. Yeah. So what I'm going to do, this is going to be that same pattern we have. I'm going to build an entire dictionary that's going to have every character. Internal temp too high. I thought I fixed this. All right, sorry about that. So what we're going to do is we have this calculate guess. The current word is going to be the current mask or the current pattern that we have. The dictionary is actually going to calculate for every character in our current set. It doesn't matter if it's already in the mask or not. And then after that, we're going to go and actually pull those out, just so we don't really need them there, but it's just that flow sort of makes the most sense. So once we have that dictionary, we want to find the one closest to the middle. So we want however many words are in our list, we want to find whatever one is closest to that divided by 2. Because that way, if it's exactly halfway there, regardless of whether we get the word or we get the letter or not, we eliminate half of the possible options, which is the best solution. Because if we do anything less or more than that, what ends up happening is, yes, we may get correct and eliminate a ton of things, but actually, if we get it wrong, we may have only eliminated like 1 or 2 things, which sucks. And we'll be here all day. So instead, we're going to do it this way. I think this will work. Pretty sure this will work. We're going to find out. So we need to take this and make it a available characters. New dictionary. I'm going to go by character int. I already had this, but I like using var. That way when you refactor, it makes everything a little bit easier. You don't have to change it everywhere, especially with generics, because then you have like types everywhere. If I want to make this a long, I'd have to change it everywhere. Now we don't. So available characters, we need to build this. So possible guesses dot for each. Possible guess, sure. We want to for each character in our possible guesses. Is this what I want? Not really. Because we don't want to add a character twice for each letter. If it has it multiple times, I don't care. At least in this solution, I don't care. Because regardless, the result is going to be the same. Either it's going to be removed or it's going to stay. So character result. So if we take, every character C in possible guesses, we're going to stick it in a separate list. Is this a good idea? Why am I doing it like this? We don't need to do it like this. We're going to do unique characters because this will work. And we're just going to do a possible guess dot unique. Whoa, that's not right. There's a way to get the distinct. So a string is just a list of characters. So this is actually going to get us all the distinct characters there. And then for each of those, what were we going to do? For each character in these distinct, in this distinct character set, we want to add it to the dictionary if it doesn't exist or increment it if it does. So if our available characters contains the key C, then we want to do available characters dot add. I think we want to remove it first. Remove C. We want to store it value equals our available characters dot get. We're going to do get at C. So just operator overloaded stuff there. And then we want to actually push out this thing, available characters dot add value or C with a value plus 1. So we're just incrementing the value by 1 every character we find, which is weird, but dictionaries are distinct. You can't have multiple entries that are the same thing. So we actually need to pull it out and then update it. We can't just keep adding to it. If it doesn't exist, we can just initialize it. So this is easier. Add C with a value of 1. So we just have 1. That's the seed. We're good. And that should build the entire dictionary. So now we have a dictionary that has every character that is in our current word set and the complete set of integers, or the number of words that each of those characters are in. So with this, I think we can figure out what we need. So I want the closest to this, the target value. The target value is going to be equal to the possible guesses dot count divided by 2. Why didn't that work? Oh, ha. Can I do a length? No. Okay. We're going to do a count divided by 2. There we go. That's the target value we want. So we have our... We're going to need to store the best value. So character of our best value, which is going to be initially nothing. Actually, we're going to have at least one thing. So what I'm going to do is this a good idea? No, this isn't a good idea. I'm going to initialize this to underscore. That's a really bad idea. We're going to do it anyway. Int best guess, or let's actually call this the best character. And then the best guess, or best value. So this is going to be the value. Effectively, we're pulling out the key pair, this entry for the dictionary. We're pulling that out and we're storing it here. So we can actually access those values and kind of cache whatever the best result was. So I'm going to do int dot min value. Ooh, why did it? There we go. Min value. So this is just super far away. I don't recommend solving things like this, but I'm going to do it just because I want to kind of move things along and try to solve this. So yeah, we have our min value here. So what this should do is this is going to be very far away. Unless we have a lot of words, there's no way this is going to come anywhere close. And as long as we have something that's positive, we're going to be closer. So we'll always be closer. So these are just 2 initial values. And then for each entry in our dictionary. So this should get us a key value pair. So what we want to do is see what the difference is between the current 2 values. So int current difference, which we could actually probably calculate this beforehand. But for now, I'm not going to actually do that. So we have the target value minus the best value, which is going to be an integer overflow by a lot. I don't think we want to do this. Now that I'm thinking about this, I think this is a bad idea. Best value 0. There we go. So if our best value is equal to 0, we're going to initialize it regardless. This will save us a whole bunch of headaches because this was going to break. We would have integer overflowed because we had min value, which with what's it called? 2's complement. There is a the minimum value is actually bigger than the possible maximum value. So if you flip those, if we subtracted them, we would have forced it to overflow, which is always bad. So we're going to avoid that issue. So if our best value is equal to 0, then the best character equals our entry.key, and our best value equals our entry.value. And then we'll just continue. So that will just select the first thing every single time, and then we'll continue to refine it over time. And so what this is doing is taking the current difference, which is equal to the target value, minus the best value, and we want the absolute value of this, because all we care about is the actual difference. We want the minimum difference, so we want whichever one is less, but it can be different on either side, so it could be bigger or it could be smaller. We don't care about that. We just want it to be as close as possible. That's why we're using an absolute value. And then we're going to do a entry difference, which is the same calculation. We're just doing the entry dot value instead of the best value. So if our entry difference is less than the current difference, then we need to update things. So our best character becomes our entry.key, and our best value becomes our entry.value. And that should be it. Then we just need to return the best character at the end. That's our best guess. And we should just repeat that. So now we just need to actually pull this together. So let's jump over here and just make it. So all we need to do is we need to issue a guess, or calculate a guess, actually. So every single time we're going to calculate a guess. I'm going to create a text searcher. This is just going to be called our search. And we're going to create it, and we're going to call this our dictionary.text. Not much to say there. It's just, we're just going to load the file, change it to a variable, and then go on. So we have the current character count. So I'm going to plug that in, search.filter count. We're going to filter things down to a character count, like so, and then I'm going to return the guess. So console.writeLine, the current best guess is 0. So we're going to do our search.calculate best guess for the current word, which is going to be empty. We can do string.empty. This should work, I think. Because we don't need anything else. There is no characters have been selected, so we don't care about that. But we are going to want to store the current string as a current found. I don't know what to call this. We're going to do just that. And so that's just going to store what the current result is, I guess. I guess we can call it that. So eventually letters get written up on the board, and you just say, okay, this goes here, so forth. That's what this is. And just to keep things consistent, let's not cut so many corners. Let's do for int I 0. This isn't really the best way to make a string. So this definitely is a corner we're cutting, but it should be fine. So we're going to do a current result plus equals just an underscore, because we don't know what any of it is. So we're just going to make everything underscores, which makes sense. So this will create a string that is just all underscores for whatever. Current word. We'll do 0 here. The current best guess is 1. So we can have current result. And so this is going to print the current best guess for the current word, given whatever you've done. And so, yeah, I think this will work. So this will give us the best initial guess. So we can actually test this. I don't know what the actual expected results for this is. I'll know tomorrow when it works or doesn't work at work. But, you know, whatever. How many characters in your word? 4. Current best guess is A. So it gives us A as our best guess. So you would guess A, and then continue on like that. So while current result dot contains a underscore. So while there's still something you're searching for, we are going to ask, and effectively this is just going to be a repeating loop that's going to say, what can we remove? So we have our current best guess. We want to get a letter. So console dot write line, what was your guess? So we want to just get this out. So character probably isn't the best way to do this, but we're going to do it anyway. Character, well, let's do a string. And this way we'll have some validation. And we can actually skip things if this doesn't work. So string guess is going to be equal to our console read line. So we're going to read in a line. And then if the guess dot length is not equal to 1, then we want to continue. Console dot write line, are you sure? So this way we can just type in a character and it'll ask us for our guess and so forth. So we don't have anything else here, but we can just test that little bit. So what this is doing is effectively saying, did you enter a 1-character thing? If we see, are you sure? We're going to say there's 5 characters in a word. Best guess is S this time. What's our guess? B. What's your guess? A. If I do AS, are you sure? So this way we kind of get that quick skip and we can actually validate some stuff. If we know there's just one, we can reduce that to a character pretty easily. So there's no issue there. What else? We have the guess. String result. Yeah, we can do result equal to the console dot read line. I'm just inserting some are you sure things here, specifically because I don't want to have to redo everything if I like type something wrong or something like that. So we should put a prompt here. Console write line. What is the current word result? Underscores for unknown. There we go. Cool. So this is just asking, what is the current result? So you do a bunch of underscores initially, and then as you get actual results, you can actually start putting things there. So if the result dot count is not equal to our character count, then we can do that are you sure thing again. So console dot write line, are you sure? And again, this is all just validation stuff to make sure we're not totally screwing things up. And it kind of prevents us from like accidentally adding or getting off by 1 with like an extra underscore somewhere, things like that. It kind of covers those cases. So now that we have this, we can have what was your guess and what is the current result, which means we can do a search dot guess, and I'm going to pass in the guess at index 0. It's a 1-character thing, so this will be the only character in the string. Plus we have a result. So I'm actually going to update our current result with this. So current result equals our result. And that only happens after validation. But then, yeah, then we can just take this. We're doing our guess, and then we have our current word and the best guess. So I think that's all we need to do. We'll see pretty quickly if this actually works. I don't know. I mean, so obviously this will break in a whole bunch of solutions. There's like guesses we can't calculate, like if we do this. But let's say our word is pizza. 5 characters. Best guess is S. Put in S. What is the word result? Pizza has nothing. So we do 5 again. Best guess is E. So what was your guess? E. Best guess is A. What was your guess? A. What is the word result? Underscore, 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 underscore A. So missing things. Saying T. What was your guess? T. There's that. L. I think we're gonna end up hanging our guy. Current best guess is underscore. Don't think it's working. I don't know why. What was our guess? If I pause this, I should be able to jump into here. That's not what I want to do. Into our text searcher. So this guy has no possible guesses. How did we eliminate pizza? I have done something horrible. Don't yell at me in the comments. What was this? Remove character. Removes it if it contains it. That makes sense. Match. Oh, hold on. Ha. That needs to be inverted. All of those knots. That was wrong. So what we were doing is we were saying, oh, I guessed A, and it wasn't there, which means only things with A are left in our list, which is wrong. That doesn't work. So by inverting that, this way we're actually removing things instead of keeping them. So let's do that pizza pizza guess again. What was our guess? S. There we go. Pizza E. A. A was our guess, and underscore 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 A. I. Underscore I. Oops, sorry, what was our guess? See, good thing we have that there. I. A. L was our guess. I. A. R is our next one. So I'm starting to think this may not solve for some things. T is our next guess. Is it though? How many things are left? Out of curiosity, how many actual possibilities are left? 10. And pizza is one of them. 3 with P. I think our search may be a bit wonky. We may need to trim that a bit. I may need to work on this a lot more because I think are we? I don't know. This seems to be working, but it doesn't. What's our guess? T. Whoa, what the heck? Oh, hot. It was paused. There we go. What is the current word result? I. A. Guess is P. And we do PI. And the next guess is N. Why is it saying N? What are the others? Oh, it's just pina or pizza. So we only get those two options, so it's just choosing the first one. Got it. So what was your guess? N? Pi? What was your guess? Current best guess is P. What? Oh, ha. Another goof. I know what we're doing. We are not pulling out. We build the dictionary here. We build our dictionary, but we never actually pull out all of the entries. So for each their character in our current word, if available characters dot contains key of that character, we want to remove it. So if we've already guessed P, we don't want to guess P again. That defeats the point. So available characters that contains key. If it contains it, then we remove it. Okay. Let's do a different word. What's a good one? Jazz? Sure. 4. What was your guess? A. What are the results? Underscore A, underscore, underscore. Best guess is S. What was your guess? S, underscore A, E, underscore E. Oops. R, guess R. Oh, shoot. And I screwed it up. I missed that. Oops. This is not the most useful user interface, but we've built this in like an hour, so I'm not too disappointed in it. What about what's a good word? Camera. Is that a good word? Sure. 6. S. What was your guess? S. A. C A. Oops. A. C A. Camera. Cool. L. L. N. M. So we guess an M. C A M. A. Boom. C. What was your guess? C. Sure. What is the current word result? C-A-M, A. And I think, oh, we don't have a word yet. Our dictionary may be, so this dictionary has like a lot of words that I don't know. They're all over the place. Like they're like crazy fish and things like that. And so I think we're running into issues where we're finding those weird things. Granted, cambia is not a weird word. That actually kind of makes sense. What was your guess? B. Okay. It is paused. I've done that twice this video. My bad. Cool. And it wants us to guess an E. So we do camera. And it wants us to guess an R. So it's got camera. So the last thing I'm going to do before we end this, I'm going to check if we have a result. So we print out the current best guess is blank, but also I want to see if search dot has solution. Then console dot write line solution found. So it'll print out the solution here. Just if you find it, then you know you found something. Search dot solution. Stop completing, please. There we go. So we need to create these, obviously, but that shouldn't be too hard. Has solution. It's going to have a solution if the possible guesses count is equal to 1. So return that. And we need to make it a function call, because otherwise that doesn't really work. Possible public string solution. And this is just going to be to get the solution. And I deleted that. There we go. Cool. Going all over the place. Sorry about that, but it's getting near the end. I'm excited. So we want to just return the first result, because that's the solution. We know there's only one, so we're going to return it. Which means if we do that camera one again, we would get that. So that's cool. Should work. What do we want to test? Pixel. Let's do pixel. That seems to fit, doesn't it? So we'll work with pixel. There are 5 characters in pixel. Start with S. What was your guess? E? Oops. There we go. R? There's no R in pixel. D? No D in pixel either. Current best guess. Oops. I keep screwing. So whenever you screw it up like that, it automatically just breaks everything. Because you've already eliminated everything that doesn't have an E there, which means if you put something else there, it eliminates everything else. So in the future, it may be a good idea to add some catch to prevent that, or just generally make this better. We could actually probably turn this into an app, and it would actually probably be pretty cool. But we're not going to do that yet. S. What's our guess? E? R? D? Cool. L? Pixel. There we go. Oops, that's not our guess. There we go. A. Pixel has no A. So we're going to do that. What was our guess? O. B. It's guessing everything but what I want it to. So part of the issue is this also doesn't consider a lot of what you're actually like guessing. So it doesn't actually consider like who you're talking with or their vocabulary, which is probably why it's taking so many. Like we already would have hung our guy if we had this, which isn't ideal, but kind of lets us go with this. G. No G, unfortunately. Input string is incorrectly formatted. So it found pixel. That's our solution. Oh, ha. I forgot a 0. Well, that was anticlimactic. I broke it with the right answer. So, yeah, we whittled it down to pixel after like 12 guesses or something, which is far more than we can actually take. But theoretically, this does harder words easier. So especially if they have like Z's in them or something like that, it gets a lot better at it. Also, if you already have a lot of things guessed, it makes it a lot better as well. So I'm going to leave it here. I'm going to open source this and hopefully improve it over time. I like the app idea. We might turn this into an app. It'll give us a good excuse to kind of pick up Xamarin again. So stay tuned for that, I guess. But yeah, that's it for now. If there's anything you guys want to see, any other suggestions or anything you have, let me know in the comments. That's how I get all of these ideas. This one is actually just something we were talking about at work, and we're like, oh, we could solve that. So I did, ish. So yeah, I'm always looking for feedback as well. So if there's something that I'm doing that you guys don't like, or you don't like this video or whatever, I'd like to know that so that I can actually kind of tune things. So don't hold back. I mean, don't be mean, but don't hold back. Because I'd much rather know what you don't like so that I can fix it rather than you just being like, nah, I'm never coming back. Because ideally, you'd stick around because that's nice. Anyway, I'm going on and on again. So, till next time, Internet. See ya.